how do you block USB? Right. So we have to talk,
super glue.
Have to work. Super glue, right?
Welcome to the Cybrary Podcast.
Well, welcome back.
Welcome back.
Welcome back.
Welcome.
Welcome back.
Welcome. Well, welcome back.
Welcome, everybody. I'm Ryan Corey, CEO and co-founder of Cybrary, and I'm excited for you to join us on today's episode. Let's jump in.
Hey, everybody. Welcome back to another episode of the Cybrary Podcast. I'm Jonathan Myers, Principal Infrastructure Engineer here at Cybrary. And today we have a couple special guests. Returning again is Mike, the VP of Engineering and Chief Information Security Officer at Cybrary. And also we have Jeff Capone today. Jeff joins us from SecureCircle, where they kind of do a bunch of zero trust DLP stuff. And so I'll turn it over to Mike for a quick intro and then off to Jeff.
So yeah, Mike Rowan, VP of Engineering and CISO here at Cybrary. Very excited to talk to Jeff. And Jeff, why don't you give us a little background on yourself?
Sure. Hi, thanks for having us, Scott. Thanks for having me, guys. My name is Jeff Capone. I'm the CEO and co-founder of SecureCircle. And what we've developed is technology to allow our customers to have what we call zero trust data protection. In other words, your data, no matter what that data is always in your control. Whether it goes into the cloud, onto endpoints, maintain control and visibility without impacting your usability. That's what we like to, how we have developed our solution and how we sell our product today.
Well, thanks for joining us.
Oh, my pleasure.
Yeah, Jeff. So quick background on you. What did you do before SecureCircle? Like what kind of led you to this path that you're on right now?
Sure. It's actually my third startup. I guess I have the disease, the entrepreneurial disease, as I call it. It's somewhat of a curse. It's hard to, I actually, it's my third. I sold my last company to Netgear, and eventually was the CTO at Netgear. And one of the things I was doing there was building storage products. And we ended up building some enterprise storage products. We're trying to go up market. And one of the things I saw from at least the mid-enterprise is that everybody spent a lot of energy securing the device, right? The device being the storage array or the device being the endpoint. You put a lot of energy in protecting the data on a file server, for example. You look at your Apple controls, who can have access to the data. And then you put a lot of energy on the device. I'm going to decide on how that data can leave that device. But essentially, you're doing all this work really to protect the data. So one of the things that when I was building storage, looked at, okay, so how can I take all the benefits that you have on the storage array and just extend those controls out to the data itself so that the same level of control over the data is maintained even after the data leaves the device that's storing the data. So we looked at how can we really do this and looked at it from a storage perspective rather than a network perspective or a device perspective. Looked at it from a data perspective because ultimately data comes to rest at some point in time. So how do you maintain that data so that you can have it secured at rest, in transit, and even in use? So no matter how it moves, whatever's using it, how can you maintain control over that data? And fundamentally, it's solved through encryption because if you think about why anybody encrypts data, encryption, if I was to ask, just a general group of people, even non-technical people, why do you encrypt data? They'll say, oh, so I can get access to it and my wife can't, or my kids can't, or the bad guys can't. And what they're really saying is I'm using encryption as a means of access control. Right? And I think it's interesting that a lot of these regulations talk about your data must be encrypted at rest. But really, if you think about it, what it's really saying is you must control who has access to the data. You should be, don't tell me how to do it, just tell me what you need, the outcome, right? And if you think about, if you had perfect access control, if I could tell you, you have perfect access control over your data no matter where your data goes, would you even worry about encryption? If you could say, I can guarantee only the folks you want to have access to your data will have access to your data no matter where your data goes, would you ever ask me, is it encrypted? You'd say, no, I'm just worried about it being protected. And one of the things that I like to talk about when it comes to access control is just analogies in normal everyday life. And one of the things when I talk to CISOs, sometimes I used to do a lot more of these speaking engagements in person. Now we're doing more on video conferencing. But I used to like try to get a reaction out of people, because one of the things I believe is when you get a reaction, when you put people on their back foot, they tend to remember you, right? So you got to find ways to get people to remember you. And one of the things I often say is that the physical world has security or access control better solved than the digital world. And everyone kind of takes a step back and says, what do you mean by that? How could the physical world have better control? I said, this is a story. This isn't true. I don't have a housekeeper, but I pretend I have a housekeeper. The story I tell is, I have a housekeeper, and I let him in the house. He's supposed to come every other Friday between 8 and noon. And I used to give him a key to my house, and he would come in every other Friday between 8 and noon. But what I didn't realize, though, is when I gave him that key, I also gave up control, because he'd come in on Saturday if he wanted to. Now, if I wanted to revoke his control, I had to change the lock. It's a pain in the neck. But I got smart. What I did is I got a smart lock, and it uses his face as his identity. And I programmed the lock to say, my housekeeper, here's his face, can come in the house every other Friday between 8 and noon. So he just shows up and he just opens the door. He thinks I leave my door open. In fact, he should, because his job is not to deal with my security problems. His job is to just go through that door. Right? He shouldn't have to think about which key to use to get into my house. That's not his problem. That's my problem. Why am I putting my burden on him? So as far as he's concerned, as long as he's doing everything he's supposed to do, he doesn't see security, nor should he. That shouldn't be his problem. Same with the digital world, right? If you're doing the right thing, passwords should go away. We talked about this before. Passwords should be gone. Nobody should worry about passwords anymore. There should be better ways to authenticate. And one of the things you should make sure is that your data, you should have control of your data no matter where you go, right? Just like I shut up the house, I open the door. If I want to access the data and I have the rights to access it, I'm on a device that has the rights, I'm a user that has the rights, and I'm a process that has the rights to read that data as if it was unprotected. That process should just be able to read the data just like nothing's changed. I shouldn't have to give that process the key like I give my housekeeper the key. That process or that application's job is not to worry about my security problems, right? I should be able to manage my own security problems and line up the access control in a way that I don't give up control in order to give access, just like with my housekeeper. So that's what we fundamentally have done at SecureCircle. We've enabled applications, users, and devices to line up as authorized to access and read data without ever giving up control of that data.
Yeah, we're on the same page with you about no more passwords. We're getting ready to implement something similar to that at Cybrary and ditch the password altogether. So we're on board there. So traditionally DLP problem, like DLP is like a weird spot for me because it seems to be such a difficult problem that like we've had DLP solutions around for years and years. And it just seems like they never work, right? Like it's always like, oh, well, this DLP solution will fix you on this and this and this. And it seems to be there's only so many providers and only so many ways that they're protecting you. And it's like, oh, but what about this? And you've just now like broken every chink in that entire application's armor that's kind of allowing access to the data. And we're doing this now, like trying to evaluate some DLP systems and like how complex of like a solution that starts to get, right? And so it's interesting to see how you guys have kind of like thought about it and kind of, I guess, reimagined the whole like use case. You kind of broke it down to the original thing. So not like nested and just slapped technology onto a 1950s thermostat. Like you actually thought about the problem people were having and kind of going about it that way. And so I think that's super interesting. And like, I hope we see more players start to kind of do things like that. And then I hope you guys kind of take off. But that's super interesting. Mike, you got any thoughts?
Yeah. It's just funny because all these are conversations you and I are having right now, right? Whether it's passwordless or the DLP stuff and how we're going to secure the data and how, we have, we also have to put so much trust in our own staff about how they use data and share data in the application. So like, we have, a CRM and things plug into that CRM, and how do we make sure that all of our users identifiable information isn't just being sent to the wrong people, and how we control that. And I'm curious sort of like how you guys fit into that and
Sure.
yeah.
Yeah, and absolutely. So if you look at the whole notion of zero trust is no trust. So you protect by default, you allow by exception, right?
Mhm.
And if you just think about firewalls back in the day, when they first rolled out, you were figuring out what sites to block. But then new sites cropped up, and you wouldn't even know they were there, so they would be allowed. So what people got smart relatively quickly is, I don't want to manage a block list. I'll manage an allowed list, so everything's blocked by default, and I'll figure out what my users need to have access to. So you button up all your unknown egress, and then control opening up egress, right? So DLP, traditional DLP, you got to go through this whole classification and everything else. So by default, your data is unprotected,
right,
and you're trying to protect by exception, which is a fundamentally flawed approach. You can't protect by exception because you can never know what you don't know. A new application comes out, which might be leaky, right? Another type of externally attached device that's not a USB device comes out. You can connect your iPhone, and maybe now the data can leak to your iPhone rather than a USB drive, right? So if a new browser comes out, so
I mean, also
DLP,
just to jump in there, like I think my problem is our marketing and product team decide that they want to ask for more additional more information from our end users, and now that it's a whole set of potentially information that we would want to protect that we didn't know. Like again, it's this like
right. So you'll
new
never know what you
information.
don't know. So that's
Right.
why if you protect by default, take a zero trust approach to your data, zero trust data security, then your data is protected by default. And so rather than having your users to make them, rather than forcing your users to make security decisions about what's important, you can now enable them to make security decisions of what's unimportant. Oh yeah, this is unimportant. I'll classify this as not important, or it'll be logged. So what you've done is with SecureCircle, you could protect everything by default and just allow what is unimportant by exception. Because when we protect data, we have no impact to the users, the usabilities, or the applications. And then you can start, the exception you now manage is what to egress out. And back to the firewall example, it's a much more secure posture to do that. So rather than imposing your end users to make security decisions, which they won't, you're actually asking them to make security decisions that are in line with them getting their job done. Oh, I have to unprotect this. Yeah, it's not protected, but I'm going to think twice because I know this is going to be an action that's going to be monitored by my SIM. So I just unprotected, who knows what, a data sheet and sent it to the customer. I know that action is monitored, and I did the right thing though, and that's okay, and it all worked for me, right? So it's all about buttoning up all that unknown egress at the data level, and then deciding on how you want to open up that egress to allow your users to do and get their jobs done. But unless you can protect by default, so unless you have a solution that's completely transparent, not going to impact applications, and we have customers that protect source code. So as soon as that source code comes out of GitHub, it's protected on the endpoint. They can still use whatever IDE they want. They can still use whatever build tools they want. They can still copy paste, do whatever they want. It's completely natural for the developers. But yet that code, that source code, even if they copy paste and save something to a text file, that text file would look similar to the source code that they checked out of the repo, and would be protected with that same policy that we apply, and then we apply encryption. But again, that text file that they created would be able to be opened and used in a natural way. But if they tried to email that to themselves, it's in an encrypted state all the time. So if they got home and tried to access that now text file on an unapproved device by an unapproved user, by an unapproved process, and they're not going to be able to get the key to read the byte ranges they need to read by that process, then it's going to see garbage, right? So your data is always in your control, yet it allows organizations, because we don't have the impact on the performance, the users, the applications, they can protect by default.
So what, I mean, that's hurts my head to think about it a little bit. So like if I am trying to collaborate with some external organization, how does that sort of work with you guys? And how do we make sure that they who should have access?
Sure.
Yeah.
So if you look, sure, that's a secure collaboration problem. So when we talk to customers, I like to separate those two. And if you look at breaches, I have some numbers. Too bad I don't have the slides in front of me. But the vast majority are accidental sharing and malicious user, these types of things. It's not intentional collaboration, so
Right.
to speak, right? So one of the things you can do, you can button up the main part of that problem. The DLP problem is making sure what shouldn't go out never goes out, right? The stuff that's not supposed to leave the organization doesn't leave the organization. So you can protect that with SecureCircle, and that's solving what the industry calls sort of the insider threat. Once you get the insider threat problem, then you can say, how do I open up egress and allow stuff that is authorized to go out and either maintain controls over it or not, right? So let me give you a couple examples. I might be an organization, I might be collecting your data, right? And I want to make sure I secure your data all the time when it's in my possession. So I secure it all the time. It's in my possession, I secure it. Now I know I'm egressing it back to you. Maybe I'm sending it through a known egress point, which might be my mail server. And it's going back. So it's Mike's data going back to Mike. So I'll have a policy set up. Mike's data goes back to Mike. It's unprotected. It goes back to Mike. I know it went back to Mike. And I have a log of that. Mike got his data back. It's not my job to protect Mike's data for Mike. Right. So you can do those types of things. And we do actually have a secure collaboration option. We call it Secure Send, that you can actually bolt on. So you can say, I'm going to take the data out of the internal protection, which is making sure the data that's inside the organization, which is not supposed to leave, but is going to leave now as an exception. And I'm going to send it through a channel, which we call Secure Send, that enables you to take data out of the inside, send it outside, but still maintain control over it. So in that particular example, maybe it is my data that I'm sending to, maybe it's my price sheet I'm sending to one of my channel partners, and I want to maintain control over my price sheet that I'm giving to my channel partner. We have a secure collaboration tool that you actually extend the controls of what we call circles that you create internally to a circle you create with that channel partner. And it's actually just collaboration through, you can collaborate through OneDrive, you can collaborate through a web interface, and these ways with those external partners. So we leverage those existing collaboration channels and still maintain control over the data as they egress through those channels. But the main problem that most organizations struggle with is making sure that the data is not supposed to leave doesn't leave, right? That's why we have firewalls. That's why we have endpoint DLP and everything else. So we button up that first and then talk to the customer how we control the egress.
Makes a lot of sense. And yeah, the sort of classic computer science is always divide and conquer, right? Figure out how to solve one problem, separate them, try not to let them all like impact each other. So it makes total sense to sort of try and solve how do we just keep the data internally? And then we'll worry about the data that leaves. I
mean, the simple answer is like today you have egress points that you don't even know about.
Yeah.
Open those. I mean, you could think of you could adopt a zero, well, it wouldn't be zero trust, but one of the things you could do is you could protect everything in the organization, but give everyone the rights to egress the data. Let everyone unprotect, right? So what you've done is you just immediately buttoned up all your unknown egress, and now everything is controlled egress. You can say whether it's a mail server, whether you just give users the ability to classify something as unimportant and it becomes unprotected, but it's an auditable event. So you have a lot of abilities to actually get your arms around the problem and then decide on how you want to implement the controls once you have your arms around the problem.
Makes a lot of sense. When you're talking to organizations, like what's sort of some of the problems or some of the things that they sort of bring up? Like, how do those conversations generally go as you're talking to them? Because I'm sort of curious as I start to wrap my head around it.
Yeah, no, it's it's a topic of conversation internally between marketing teams and the sales teams, right? So, and the answer really depends who you're talking to. So if you're talking to a larger enterprise, they're trained to think, discover, classify, protect. So no matter how hard you try to put the problem on its head, say, no, you can protect by default and allow by exception, they want to think, basically, they don't want to look at it this way, but it's allow by default and protect by exception. In other words, I'll go and discover the real important stuff and put a tag on it and then set up a DLP rule if I see that tag to block it from going to USB, right? Trying to get people over the hump of you can protect by exception and allow by default, and the fact that important data doesn't, where your important data is, right? If I was to ask most people, where's your important data? They say, oh, well, it's in Workday, or it's in Salesforce. It's in these services, right? A lot of times I joke around. I say, if I give you a discovery tool, where are you going to point it? If you don't know where to point it, how can I discover it, right? So you point at the sky, right? So when we get into these conversations, they're like, well, I know what my data is moving forward. Yeah, it's in Workday, it's in ServiceNow, it's in this, typically the applications we see, or it's on a file server. And we say, okay, let's point our solution there, protect all that bleeding that might happen moving forward, and then we'll go worry about the sins of the past. Sure, the sins of the past might happen, but to be perfectly frank, those sins of the past, those problems decay over time, so to speak. The stuff that is out in the wild, we can talk about how we can go out and discover and those types of things, but that's not the most relevant problem. The more relevant problem is, how do you protect all the important stuff moving forward?
Well, how do you stop the bleeding? That's right. You have a patient that's on the table. Step one, stop the bleeding.
On that problem, right? Don't worry about what's out in the wild from 5 years ago on someone's USB drive sitting in a closet, right? I mean, that's not your top priority. Top priority is making sure that you have control around the data that's leaving these relevant and timely sources of data. Right? And so that's where we like to steer the discussion. But often we have to talk about, how do you block USB? Well, I mean, I think the audience and yourself have enough understanding of our technology where the answer is, who cares?
Right. Why bother?
Why bother? Right. But you'll get these RFPs that will say, how do you block USB? Right. So we have to talk, well,
super glue.
Don't have to worry. Super glue, right. So those are some of the challenges we face when you're solving a traditional problem in a more fundamental way. And so those are some of the challenges we see. But customers are smart; they get it pretty quickly. But out of the gate, a lot of people are trained to think in a very traditional way, and getting them to just say, "Look, yeah, Workday, ServiceNow, Salesforce, let's button those up. Git is a big one. We see that half the time. We'll just button up Git." And that, in fact, Tesla had a. I don't know if you saw. I think it was over the weekend. A Tesla developer accidentally put source code on his. Maybe I shouldn't say this. Maybe we should. No, it's in the news, so I think it's fine. It's fine. I think he put it on his Dropbox, his personal Dropbox, and leaked, and that was accidental. But here's another interesting bit. We just kind of riffing here. The whole Waymo, Google breach that happened in the news around source. Uber. Yeah, correct. Sorry about that. Interesting that the courts, the ruling could have been less severe if they took more. So let me take a step back and maybe want to edit this out. If you look at protection for IP, source code being IP, the patent office is very unlikely to give software patents these days. They've actually pulled back from that. So organizations have to treat intellectual property, source code, as trade secrets. Now, if somebody breaches trade secrets and this goes to court, you have to show you took reasonable measures to protect your trade secrets. Otherwise, you can't claim it was a trade secret. Right. So if source code can't be protected by patents, and you have to show reasonable measures, and it can just easily be egressed out through someone's Dropbox account, can you really claim someone stole it? Right?
Yeah.
So that's a big problem, right? So and that's where we come in, because we can show, you absolutely did everything possible to protect that source code, right? In fact, egressing it through Dropbox would not have happened. Well, the data would have went out, but it would have been encrypted. So one of the things that I think the industry as a whole, when it comes to source code protection, you don't have protection through patents anymore. If you're claiming something as a trade secret and someone accidentally steals it or accidentally loses it, I should say, it's going to be hard in court to claim you really had a trade secret because you didn't take reasonable measures to protect it.
And it sort of, so my background as a software engineer, it starts to hit on some things that I don't think And I don't want to start like a religious debate or war over this, but I don't think companies realize how much they benefit from the fact that over time, software engineers build up a library of stuff that they've done at other places. The source code itself, like, yes, in whole, given to some other company, maybe has some value, and I can look through it, whether it's from a security perspective and maybe look for vulnerabilities, or from a competing business perspective. But the fact of the matter is, if I was going to try and build a competing service from a software perspective, looking through another company's source code is like the worst way to go about it, because it's just built up on all this stuff, right? And so, so this idea, but at the same time, like, I have taken over the course of my career some libraries that I've written and like been able to look back at them and be like, that's how I solved that problem in the past. That's awesome. And I'm working on a problem today that's similar, and so I can look back at it. And I don't think, it's just like push pull. Like, I get it, like from a company business perspective, right?
Yeah. No, but yeah. So if so what you're saying, which I definitely understand, is that the source code is only as valuable as the people who wrote it. Right?
Well, to a certain extent, and also it's as valuable as the people who wrote it. And companies do get a lot of benefit when they hire a software engineer if they've worked on other things, and they
should know about that benefit. By the way, you wouldn't want that to leak into your repo.
Oh yeah, and reasons, right. I'm not even talking about like taking like code verbatim from some project and putting it from some previous company in another. But I do think you sort of build up these things, and it was more prevalent in the early days. I think it's a lot harder these days. And I think there's more open source project, and there's less need for it. But like in the 90s, when I moved from job to job, the fact that I still had access to the source code that I wrote at my first job benefited my employer, not because I used that source code, but because I was able to refer back to the knowledge I had built up over time. Right. And I get it. And from a business perspective, it's terrible, right? I don't want my source code. I don't want my engineers taking the source code and making it available and blah, blah, blah. Well, so I get both sides.
But even just from a, if you just think about your source code as being an asset on your balance sheet,
right,
which it is for a lot of companies, if you're not protecting that asset, you're not going to be able to claim it has value.
Right.
So if you're a company and you want to go sell your company at some point in time, and it's an asset sale, they're going to look at your assets, source code being one of your assets. If everything was open source and you didn't protect it, then you can't put any value on that asset, right? So being able to have control over something that is on the balance sheet, such as source code, intellectual property, is extremely valuable from a business perspective. Now, you have to, what we like to talk about internally is, because we are developers as well, how can you build a security product where the developers aren't going to complain? And we've done that, right? So we completely work transparently. Developers don't even realize that SecureCircle is in the mix. It gets checked out, transparently gets protected on when it lands on the endpoint. They use all their build tools, no performance impact. And actually, we do egress it back out when it goes back to a known location, which is GitHub or GitLab or whatever the repo that they're actually checking the code back into. So those tools inside the cloud still function as normal. But as it's leaving the control of the cloud or that repository, we're extending those controls down to the endpoint, the same controls they had over when it was in the centralized repository. So yeah, I understand both sides of the equation.
And I want to make it clear that I'm not even talking about the entire, right? Obviously, the entire repo is a totally different case than a snippet of code, a block of, right? And I'm curious, like, what's the impact to a software engineer who's trying to use Stack Exchange and trying to, like, maybe ask a question about, hey, I have the source code. This is how it works. It's not working the way I want it to work. Like, what's sort of the impact? How do you guys, like, how does that sort of get handled? Or is that?
It depends. So when you think about security, it's breadth and depth, of course, right? So, and we're data-centric protection. So you can choose how you want to protect that data. It's not files, it's truly the data. It's the data inside the files. File happens to be a control point. So does the clipboard. The clipboard is a control point, right? Network is a control point, right? So what we enable you to do when you define a data policy, the policy that you want to put around your data, you can add depth features. So you can say, hey, look, any data in this, what we call circle, which is really just a collection of data and access control policies around it. If this data is in the clipboard, don't allow it to go to these processes. So you can actually put a policy around the clipboard, a policy around the network as well, right? So you can add those depth features. So if you want to let people, in all honesty, I would let people copy and paste into Slack, because a little snippet of code is not valuable. It's the whole repo. I mean, we're developers. We know that you really, unless you have the whole repo, it's not, protecting one file or egressing one file is not going to be in the world, because someone can really rewrite that. But if you lost the whole repo, that's a different story. And developers do check out the entire repository to do their builds locally and these types of things, right? So that is a major concern. But me, if I was a VP of engineering, I wouldn't be so concerned about a snippet of code, a function. But I let that go through Slack. But for my developers to do, yeah, sure, I would allow copy paste to Slack.
And that's the cool thing about your solution, right? You can do that, right? Like that's the
Sure.
thing. It's like I imagine you can even put that control down, that decision making down. Can you put it down at the engineer level and say like, hey, if you're one of these, if you're within this group of people, then you can copy and paste this. But if for some reason somebody else had access to source code, maybe they can't, or
you can, yeah. So you can. We don't have any identity. We don't have any notion of identity. So we actually we enforce at the device level. You can bring your own identity and add that to a data policy to enforce user identity on the data policy that you've created. So if you want to say these groups of users put data in this circle, have the ability to copy and paste into Slack, you could say that for these groups of users. So it'd be all by your security group policies. You can define those rules.
very cool.
But a lot of people stay away from that, because then you end up with a management nightmare. So it's typically fix the big problems. And,
Right.
If you really want to dial in and go after that sort of level of control, it's there. Is it used in practice in some really particular scenarios? It is. But in general, it's the large coarse grain controls that really went out.
Yeah, definitely.
because-
I mean, I think, well, go ahead, Jonathan.
Yeah, because all you care about is the data, effectively, right? Like, I don't care if it's Jim or John or Jack. Like, it's the data that's important.
Right.
So,
Right.
and
you
I
don't
think
want
that's
to put
where
trust in the user, really. You don't want to say, well, Jim, I'll let copy paste. John, I won't, because, why do you trust one versus the other, and, everything else? Like, today you might be a friend, tomorrow you might be an enemy. So, but I agree. It should be
Right, and the data is the data, right? Either I want the data there, or I don't want the data. Like either the
That's
data is
right.
important or it's not, right? I don't.
Right.
This way, I can actually say, you know what, I don't have to worry about who I have faith in their decision making capabilities.
That's right.
Yeah, because I think my nightmare comes from previously working for a DLP company and seeing, we were acquired by a DLP company, and seeing how they configure the rules and stuff like that. And that seemed to be like a nightmare that hadn't evolved since, I think, ever. So when I first, what was this? Like 2018, and looking at how they're configuring these rules, like I had flashbacks to like the early days of Microsoft Active Directory and like all the security policies you could do. It seemed to be like the most confusing thing, and like the most nightmare to like catch every situation.
Well, because it's
and
exhaustive.
like you said,
Well,
Yeah,
It's an
but
exhaustive policy, and you can you'll get exhausted before before you're able to protect everything.
yeah,
And
and then
you'll
it all
never know what
depended
you
on
don't
how.
know.
Yeah, and then it was all dependent on how you classified your data. So like if the data had no tags or no like knowledge that it was good or bad, like you just miss it, like it'd be
Well,
gone.
not only that, but tags are mutable.
Yeah.
Right. They don't persist. Right. So we didn't get into a lot of technical details, but we're able to identify what we call binary DNA. Right. So we're able to take a blob of data, binary data sequences, strings of zeros and ones, and identify these features in these sequences, zeros and ones. And those are immutable. You can actually, no matter how that data is transformed, we can measure similarity between these binary strings, which are immutable across transformations. And now we get in the weeds of things. But so we actually track those sequences of zeros and ones that are immutable. We don't rely on tags. So
Reminds me of the Windows. There's the new guy on YouTube that's doing the secret history of Windows.
Mhm.
And he talks about like how they made their like activation system, like the Windows activation system.
Mhm.
And so they had to develop this way of knowing if it was a new computer or not. And so the problem was, well, like how many pieces am I allowed to change in the computer before it's a new computer or not. And so like they're trying to, I think they were doing very similar things to determine like, well, had enough like entropy occurred in this like string of data to determine if it was like a new computer or not.
Well, I mean, it's essentially, I mean, so entropy is information. If, in other words, so if you just had the letter A and you had 10 megabytes of the letter A in a file and you copied 5 megabytes, then you haven't moved any information, right? So honestly, that would be we have what we recommend is 256 bytes of unique bytes, we say, because people don't understand what information is. Information is a measure of entropy. Go down that path someday if anyone would like to talk about information theory. But in any case,
is it James Galecki book?
Yeah, Shannon did it. Klaus Shannon came up with this whole notion of information theory and how much bits you can send through a noisy channel. I used to be a professor of digital communications, so I used to teach these things. And so, but in any case,
so what we're saying is we need to ship you a blackboard.
That would be nice. That would be nice. So I'm happy to teach a digital communications class. I haven't done it in 20 years, but it'd be a lot of fun. But we used to talk about information theory, and so it's the more randomness you have, the more information you have, and if you don't have any randomness, then you're not conveying any information. So we won't detect a derivative if there's no new information in that derivative or no information at all. Right? So, any case, maybe that's another deep technical session we get into. I'd love to talk about how that piece of it works.
Yeah, but I mean, going back a little bit, but the idea that as a file or as the information in the file changes, it's potentially goes from being information that you did want protected to information that's no longer requiring that same level of protection. Is that fair?
Well, I mean, you can set your threshold where you like. So if I want to make sure, if I say that here's data that I want to protect, let's just say it's a megabyte, and anything that's 256 megabytes or larger of similarity to this 1 megabyte binary string, I want to protect it wherever it goes. So if anyone takes, you can set this threshold whatever you like, but if someone takes as little as 256 megabytes of information out of this, 256 bytes of information out of this megabyte file and put it in something else, that's something else we call a derivative, and that derivative would be protected with the same data policy as that megabyte file. But you can set it to whatever granularity you want. You could say a half a megabyte of information has to move for something to be classified as a derivative. But 256 bytes of information, and again, it could be audio, video, text. It doesn't matter. This technique works across all types of media. Is a good measure we find for most organizations. So from a text perspective, 256 bytes is like a paragraph. In all honesty, anything less than a paragraph in my mind is probably not worth protecting, because I can just see with my eyes and memorize it, right? I mean, so 256 bytes of information is a decent threshold.
Seems like you guys would be good at detecting malware.
So, well, one of the things that we do good, one of the things we didn't talk about, which is really useful, part of our product, although we didn't set out to design to solve the ransomware problem, we solve one half of the problem, right? So half of the problem is they lock the data on your device and you can't get to your data. The solution to that is backup. So if you back up the data, of course you have to restore and you get some downtime, those types of things.
And you also have to catch it soon enough so that, like, if you have 6 months of backups but only learn about the
that's true too, right? Yeah, right.
Malware.
That's one of it, right? But the other part of the problem is they'll take the data and say, hey, if you don't pay me, I'll extort what's in this data. Right. So malware would never be an allowed process in our world. So if malware was on your machine and read those bytes and piped it to, some web server that they're going to try to extort you, they'd have a bunch of garbage. I mean, to some degree, you can't extort already extorted data. So, I mean, think of what we do. We're not extorting you, but we're protecting your data with the same technique ransomware does. And then we give you the ability to control access. What ransomware is doing is preventing you from having access to your own data. So if we get in there first, then we can solve that part of the ransomware problem, that nobody could ever extort you for exposing what's in that data. They could lock you out of the data if they got to it, but they wouldn't be able to extort you from what was inside that data. If we were protecting it and somebody ransomware the data that's already on your endpoint, then yeah, sure, they're going to lock us out of getting to our stuff to give you the keys to get to your stuff. But if they exfiltrated it, which is what they do nowadays, and then hold you, they'll say, well, let's say they got access to your quarterly earnings before you wanted to announce them in your public company. I'm going to announce your earnings early. And because that's a big cost to organizations because they have to early announce the numbers. So yeah, I mean, if you had someone's quarterly data before they became public information, you could hold them. Just locking them out of that data would be a problem. They can just roll back to a previous version and do a restore. But yeah, releasing that data to the public would be a huge financial loss to a lot of organizations, and we would absolutely solve that problem.
So you guys do a lot through the endpoint. How does that kind of translate to more of like these SaaS type solutions? Is it all still kind of goes back to the endpoint, or is there some other kind of thing happening?
Yeah, so we get a lot of customers that say, okay, I like how you decouple access from the device. So if you look at what we've done is we've given access control to the data. No matter where the data goes, the access control follows the data rather than the access control of the file system on the device. So we've decoupled access control from the file system, the device, to the data itself. So that the device can be open to the world. The same analogy can apply in the cloud. So using AWS terminology, if you think about a bucket in S3, access control is on the bucket. The objects inside are protected by the access controls on that bucket. But if I move an object from one bucket to another, I've just potentially exposed my object. So we actually do have quite a few customers saying, okay, we want to extend this type of concept of separating the access control from the device, in this case, the device being the bucket, to just the data itself. So protect the objects with SecureCircle, and then how do you get in between the reading of that object and the process that needs to read the object? There's a few different ways that we've done this. We haven't productized it, but we've done this with some custom deployments. We've used Lambda functions and controlled access to the bucket through those Lambda functions. That's one thing. We've actually modified the SDKs they use to read objects in S3. So we've inserted ourselves into those SDKs so that only those SDKs can authenticate and essentially act like a device. And the process that are going through those SDKs can read the bytes that are now encrypted objects.
Similar to how malware would do it.
Similar to probably how malware would do it, right? But in all honesty, right? I mean, isn't an antivirus more or less a virus, but working in a good manner?
Oh yeah, absolutely. Yeah.
So, or vaccine, I should say. So, yeah.
Fascinating.
So how does that work with like Salesforce, for instance? Like, are you guys just like a plug-in app, or is there some sort of? I guess that's where I'm kind of confused. Like I get everything locally.
Yeah, right. Okay, so this is another. I don't know how deep we want to go in all these talks.
We can go deep.
So this is another great question. So, what happens a lot of time? Well, not often we get to these discussions. Okay, so here at Salesforce, I create my zero trust policy for accessing the front door of Salesforce. Right. So what that is I make sure, let's say, in a ideal world, I have MDM on my device. I have probably some SCIM authentication, some SSO authentication, and I have some EDR on my device, CrowdStrike. So which means I have control of my device, I have control of my user, and I have control of the application, and I have some sort of software that can protect the device from malware and these types of things. So I can make sure that the user lines up, the device lines up before I open the front door to Salesforce. So there's no viruses on the device. But now when I open that front door, the data comes out, and the data is under control of the user that owns the device if SecureCircle is not involved. So what we talk about is when people want to line up that front door for zero trust, consider the data. So make sure as part of that compliance posture of the device, which is enforced through MDM, that SecureCircle, in addition to CrowdStrike, is on that endpoint. So now you can make sure there's no viruses before you allow that device to have access to the front door. And now you can make sure the device and the user can download the data because SecureCircle is on the device. And you know that you'll still have control over the data that just left Salesforce. So basically by using the security posture, the device trust. Okta has device trust, or you can enforce compliance posture with your MDM. Then your SAML assertion will succeed provided SecureCircle is on that device. But if SecureCircle is not on that device, your MDM, you'll fail that assertion test with your MDM, because your MDM will check to make sure that SecureCircle is part of the compliance posture. If it's not, then the token doesn't get signed, and you won't get your token all the way chained back to Salesforce or any other SaaS provider that's tied into your SAML authentication chain. That's a pristine world, right? That's kind of what we hope we walk into, right? But the truth is, the MDMs aren't perfect sometimes and everything else. So one of the things, especially as we're going more mid-market, is we are going to be releasing, we will be an assertion as well. So you'll be able to allow, just like you check with the MDM to see if with the SAML assertion, see if the device is compliant. You can check with SecureCircle, see if SecureCircle is compliant. To see if the device has SecureCircle on it, we'll know that. And if it doesn't, we can even revoke the token as well, right? To make sure that the person can't get access to that SaaS service. So basically making sure SecureCircle is on that device before the front door is opened is how we protect Salesforce. So no plugin required, nothing like that. Just make sure SecureCircle is part of that device posture or device trust, however you want to implement it, or will be part of that assertion chain as well in the near future before you allow authentication. So it's all tied into SAML.
Okay, cool. Yeah, we've been looking at a bunch of the, like, I guess they call it context aware access now, and stuff like that. So yeah, that's super interesting. Yeah. Sorry.
Yeah, that's another
going down that.
Right. You keep saying these things that cause us to have to stop to think.
Well, another
fascinating to think about.
So here's the other one that is useful too with SecureCircle. So we don't provide users. We don't do we enable access control. We aren't access control, right? So we enable access control in your data, which is really nice because now you can bring conditional access to your data, right? So you might have data on your endpoint today, and if it's under control by SecureCircle, or if it's enabled by SecureCircle, you can deploy conditional access now on the data, right? Where if there's no control of the data, once you give someone the data, they have the data. But now with SecureCircle Plex, not only can you say they have it or they don't, but you can do conditional access on the data. Maybe they're in a part of the world you don't want them to be in, and they shouldn't even see it on their screen, the data that's in that Word file. You could allow conditional access based on those rules. So we could actually plug into a conditional access offering as well to provide that on the data that's already left the cloud where conditional access traditionally is deployed, but now even on the device. So extend conditional access all the way to the data.
Yeah.
I mean, it is that simple, right? I mean,
right.
And honestly, we get dragged going back to the whole just traditional DLP. Some people will just say this, we just want to protect PII. I don't care,
right.
PHI, that's it. So, of course we added regex and all that stuff. Just, okay, you just want that? Click. And again, this is not my vision, but you get, depending on who you're talking to, you want to make sure you're giving the customer what they want. If they just want to check a box and say all PII that comes out of file server, comes out of Workday is protected, then great, we'll give them that, right? So
yeah, and I think you just that's another one of our wheelhouses as well, is when we're talking about these next generation technologies, whatever it is in security, as things move forward, these questionnaires that Jonathan and I are forced to fill out that are like, do you have a DLP solution? At least you guys have DLP, at least you guys are a DLP solution. So if we were to move forward with you, we can check that box. But
yeah, you can check the box, right?
Right. But in other cases, they're like, what's
IPS and IDS.
Exactly. IPS and IDS are right. For yeah. And so it's,
but if you're a cloud-born company, you're just using these services, you don't have any infrastructure necessarily. So how is that even relevant, right? So,
right.
You can't tell that to the person that gave you the questionnaire.
Right. You can't tell that to You can't tell that to a questionnaire is the important, right? If you don't check that box, you're now it's got to get escalated to a point where chances are they're just whoever's in charge of the purchasing is just going to move on to the next company because you need to get authorization from someone who's not going to bother.
Correct.
Yeah. Our problem was we're running Kubernetes, and they were just naming all these traditional, do you have a firewall and all these traditional things. And we're like, well, no, we run a website, firewall doesn't really do anything if you only open one port, so, but yeah.
Yeah. It's interesting because when the technology changes, but the the templates people use to evaluate things. It's always
Well, they're so far delayed.
Right. Well, and also it gets back to what you said at the very, very beginning, which is don't tell me how to do the thing. Just ask me if I'm doing it. Right. Are you protecting my data are you protecting it at rest? Are you protecting it in transit? Are you protecting it under usage? All of those different things. How are you doing that? Yeah. Don't tell me exactly
don't tell me to encrypt my data. I mean, honestly,
right.
I mean, I could have the key in the same folder as the files that are encrypted. What good is
that? I can do it poorly. Right. I can encrypt it poorly.
So what you should say is, do you have reasonable controls over your data? And then show me. When you get audited, show me. I use SecureCircle. I have great control over my data. No matter where it goes, I have control. Here's a nice report. Every person that I gave access had access and nobody else, right? Showing them that it's encrypted, but the key's right next to it. I mean, that shouldn't be the result of an audit. Yeah, they had encryption. It should be here. They had access control over the data, and they showed me that only who they enabled access truly had access to the report, right? That's what you need to show, that you're doing what you say you're doing. Encryption is just, to me, it's a means to an end, right? So
preach. I mean, that's the problem, right? I mean,
there is one question though that I would say that I can think of that would go against this norm, and it's the question of, are your passwords hashed and salted? Right? Because people can encrypt passwords, and I've seen questionnaires where it's like, is your password encrypted? And it's like, well, yeah, but if I have the key, I can decrypt your password, and thus
unless that file is protected by SecureCircle. So I'll give you an interesting story. We have a lot of customers, SVN customers, that will, or not just SVN, but even get that you'll use a client-side key for authentication to access the repo. Right? So they'll protect that key with SecureCircle and put, let's say, Git in the allow process. So if Git is allowed to read the key, it can go and authenticate and check out. But if you take that device, that process even, or that user out of, quote, the data policy of the circle, then it can't even read that key. So you can't authenticate.
So thank you for joining us. Any final thoughts or anything before we go?
If anyone's interested in complete control over their data, I'm happy to have an in-depth discussion about any of the topics we talked about on this session. And just reach out to SecureCircle, and I'm always happy to talk about what we do.
Awesome. And then I think we should look at maybe having you back on, and we're going to have some serious discussions about information theory and fun stuff like that. So Jeff, awesome. Thanks for joining us. Mike, it was always good to talk to you. Awesome. Thanks, guys. We'll see you on the next podcast.
Thank you so much. Appreciate your time.